Good morning and welcome to Avanti's webinar series, our next iteration and presentation. Our topic today is injection grouting for industrial applications, cost-effective rehabilitation for concrete structures. My name is Britt Babcock. I'm the president of Avanti, and thank you for joining us this morning while we're all trying to be safe and get through this pandemic that we're in right now. Avanti definitely recognizes what we're all going through, and we appreciate and support everybody's well-being, safety for our friends, our families, our partners, clients, and customers, and appreciate your time today. And we're looking forward to have a great hour with you. So again, our topic is injection grouting for industrial applications, cost-effective rehabilitation for concrete structures. I have on the call with me today Mr. Chris Hamilton. Actually, I have two Chris Hamiltons, not to be confused, but I'll give some explanation to that. I have Chris Hamilton, our Southeast Regional Manager that we affectionately call OC. OC stands for Original Chris. Chris has been with Avanti for almost 5 years now and is a great teammate, a great asset to be a part of our team, highly knowledgeable about grouting. And he's going to share his wealth and knowledge with you today. I also have Christopher M. Hamilton. He's come on board with us just about 2 years ago now, and we affectionately call him CH2. He is our Northeast Regional Manager, and Chris comes with a lot of construction knowledge on coatings and a lot of pre-knowledge on our injection grouts as well. And his wealth of knowledge will be shared with you today as well. Again, my name is Britt Babcock. I'm the president of Avanti. Been with Avanti for 10 years now and been in the construction and materials supply aspect of things for 25 plus years. Before we get started though, one of the things we like to do, and we're going to do this throughout, is we're going to ask you a question to be a poll. We're going to do that 3 or 4 times. But I also want to remind you that if you have questions during the presentation, please feel free to jump into the question box, present those to us. We will have a Q&A session at the end of the presentation. So if you have questions, type them in there. We'll get those. I hope we can address all of them. But if not, we will follow up with you afterwards and look forward to seeing what you guys have. It's going to be a ton of great questions, I'm sure. But to get started, let's take a look at our poll question. Poll question number 1 is going to be, what is the level of familiarity or experience with urethane and or epoxy injection grouting? What is your level of familiarity or experience with urethane or epoxy injection grouting? So we have 4 choices: no experience, rarely, sometimes, or very familiar and experience. So again, no experience, rarely, sometimes, or very familiar. We'll give that a few seconds to let everybody respond. So what is the level of familiarity or experience with urethane or injection grouting? So the results for that are, all right, it's a good spread across all the different levels of experience. So it looks like we've got 15% with no experience at all, rarely 32%, sometimes, and very familiar. So good spread on the knowledge base of our audience today. So I'm excited. This is going to be a very informative presentation. So I'm going to hand it off now to CH2, Christopher M. Hamilton, and he's going to start us off. Welcome, Chris. Thank you for joining us.
Thank you, Britt. Hello, everybody. As Britt said, my name is Christopher Hamilton. I'm one of the 2 Chris's you're going to hear today. I cover the Northeast. I go from Washington, D.C. up to Maine. What I'm going to do here at the beginning is kind of walk through the basis of the presentation here, kind of give you a little bit of a background of what are injection grouts, kind of where they're used, and then we're going to kind of walk through the presentation from there. So as far as what injection grouts are, they're liquid resins that turn into an impermeable solid within a predictable amount of time. Later on, when Chris goes through the different types of products, he'll talk about what influences that amount of time and how we can influence them in the field. But for right now, it is fairly predictable, and a lot of times in the field, we can actually help you isolate time frames for the material to react. So Where are products used? A lot of subways and tunnels have issues with infiltration coming in through cracks in the wall. You got joints. Basically, a lot of our products are used for curtain grouting tunnels, for stabilizing soils around the outside of structures, preventing water from coming in. We're used heavily in mines, whether it be in the shafts for preventing infiltration in the shafts, for stabilizing soils on tailings dams to prevent further erosion. Products have been used for injection in joints on concrete and earthen dam or concrete dams. Our ultrafine product was actually used here on the Hoover Dam for stabilizing or for sealing small rock fissures, preventing water infiltration when some of the tunnels were being drilled. We also have a number of different slab and structural high density foams that can be used for lifting slabs in a warehouse to prevent slab curl or even residential sidewalks. Our products have been used in underground structures and telecom vaults. Probably one of the cool case issues we'll talk about later is a job we did with the PSE&G last year, basically preventing water infiltration into a natural gas main that went underneath a turnpike. But our products have also been used for stopping water from coming through conduits, for stabilizing soils and preventing water from coming into underground electrical vaults. We also do a lot with pre-excavation grouting for preventing water from coming into areas we're going to be digging pits. We also do stabilization for the sides of excavations to prevent any type of sloughing or losing any soils. We've been using hazardous waste containment for preventing nuclear waste from leaching out, all the way to different chemicals that may leach into the Chesapeake Bay, which a couple of my contractors are currently working on. We're used heavily in the municipal field for stopping all different types of points of infiltration, whether it be cracks in manholes, precast joints, mainline pipe joints, lateral connections, or even lateral joints. Basically anywhere where there's infiltration in the municipal environment. We're used heavily in parking garages. So a lot of times you have below grade parking garages, especially in larger cities. They'll have issues with infiltration coming through walls in stairwells, even joints in the floors in different areas. Our products have been used for stabilizing soils on the outside of culverts to prevent further erosion of the soils, also prevent water from coming in through joints in the culverts. Also, we've been used for preventing water from coming in through catch basins and preventing soils from eroding from around the outside of catch basins. Elevators or elevator pits are inspected frequently. Many polyurethane products have been used for preventing infiltration and stabilizing the soils around the outside of the elevator pits to prevent infiltration, also to prevent exfiltration of different oils that are down in those pits. I'm going to flip it back to Britt now to go through poll question number 2.
All right, thank you, Chris. Very informative. So yeah, second poll question now for our audience. I appreciate everybody. What percentage of your workload would be classified as concrete restoration or repair? So we've got 4 choices here again. None, less than 25%, 25 to 50, or more than 50%. So 4 choices there. Everybody respond to that, and we'll take a look at the results here in just a few seconds. What percentage of your workload would be classified as concrete restoration repair? All right, just give it a few more moments here. Let everybody respond. All right. Good spread again. It looks like we're in the median of the curve here. Less than 25%, 41% of us. 25 to 50 is another 41, and 2% is none, and more than 50% is 16%. So interesting spread on our audience. Thank you so much for responding to that. Now we're going to hear from Original Chris Hamilton, our Southeast Regional Manager. Original Chris, would you please take it away?
Thank you, Britt. As Britt mentioned, my name is Chris Hamilton, the OC, as I'm referred to in Avanti. I cover the Southeast United States, essentially everything Virginia down to Florida and over to Mississippi. So in this portion, we're going to talk about something that's extremely important, whether you're an experienced applicator or whether this is something brand new to you, which is the criteria for selecting the right grout. This is probably, if I had to put a number, probably 50 to 60% of what we do at Avanti is helping our customers, no matter what sector or industry they're in, choose the right grout. And with that being said, it's really important to tell you that there's no one size fits all grout for every application. And as you can see from the panels on this first slide, there's all kinds of different grouts, compositions, chemical bases, and we're going to go through where each one of those products fits. So there are three major families of injection grouts, groups, if you will. Those are polyurethanes, acrylics and acrylates, and epoxies. Of those three families, the polyurethanes have two subsets or two subfamilies, if you will, one being hydrophilic foams, the other being hydrophobic foams. I'm going to tell you some more specific things about these two subsets, but the most important thing I can tell you is they are truly night and day different from one another. So hydrophilic foams, as the name suggests, they love water. They have a strong affinity for water. They need a lot of water to react. They have moderate expansion. When we say moderate expansion, that's kind of a generic term, but what we mean by that is somewhere between 400 and 600% expansion. And most of our hydrophilic foams have potable water approvals. Now, why is that important? Well, obviously, if you're working on water distribution or a potable water plant, then you need to have potable water approvals. But even in the storm sewer and sanitary sewer applications, where potable water approvals may not be necessary, it does kind of reinforce some peace of mind about environmental impact. So then hydrophobic foams, again, night and day different. They have little or no affinity for water. And what we kind of mean by that is they're very sensitive to moisture. They don't need a lot of water or moisture to react. They use a catalyst. Most hydrophobics use a catalyst. Some people look at that one of two ways. You might look at that and saying, well, that's an additional component, and maybe that complicates matters, which it doesn't really complicate things, but it is an additional component. But it also gives you the ability to adjust your reaction time, which we'll talk a little bit more about. Most hydrophobic foams have high expansion rates, can be anywhere from 400% all the way up to 3,000%. So a gallon of hydrophobic polyurethane resin, in a lot of cases, will go much further than a gallon of hydrophilic. You can accelerate, again, with the catalyst. And our hydrophobic foams, at least most of them, have potable water approvals as well. So just to dig a little deeper into the hydrophilics and hydrophobics, almost all the hydrophilics will cure to be flexible. And that's really important because if you have a dynamic defect, let's say, for instance, a crack in a concrete tank wall, we know that that crack's going to continue to move via thermal expansion contraction. We don't want to use something rigid in a setting like that because the first time the wall goes through a thermal cycle, then something rigid is not going to move with it, whereas a flexible cured solid will actually accommodate the movement and move with it. Next is expansion. I mentioned earlier that most hydrophilic foams expand between 400 and 600%, or 4 to 6 times their initial volume. Your hydrophilic foams do not use a catalyst. They are a single component. And again, you can look at that one of two ways. You can look at it as a simplified way of applying the grout, but then you also lose the ability to adjust or modify your reaction times. All right. So then hydrophilics, when you to look at those, what we're going to see here is you've got a hydrophilic cup sample. This is what we just referred to as a cup sample. So you've got about the same amount of water in the cup on the right. Okay, so you could call it 1-to-1 water to grout. Those two are mixed. You notice right away that just about any product you're using, as soon as they begin to react with water, they turn a very milky white, so you know you're getting reaction. And then, as we mentioned earlier, now you've got an expansion rate of about 400 to 600%, somewhere in that neighborhood. That is flexible. All right. Hydrophobics. Hydrophobics in the past, if you chose a hydrophobic, it was going to cure rigid or semi-rigid, and that was just the way it was. But over the years, we've developed a flexible hydrophobic, which has been used a lot in dynamic environments, and it's actually one of my favorite go-to products. The expansion rates, again, on hydrophobics are very, very vast. There's a wide variation, so it can be 400% on some, all the way up to 3,000% on others. All right. As I mentioned earlier, the hydrophobics use a catalyst, which can help you modify the reaction time on site. That's very handy. And the gel rates, just like with hydrophilics and like with epoxies and like with concrete, the gel rate is, or reaction time, is always heavily dependent upon the temperature. All right. So what do hydrophobics look like? Well, very different, as I mentioned. This is a 1-to-1 hydrophobic. All right, so it's a dual component hydrophobic. Those two are mixed together. All right, now remember the expansion you saw in the hydrophilic. When these two expand, or when this hydrophobic grout expands, now you've got about a 2,000 to 3,000% expansion rate. Okay. So then those are the urethanes. Now we get into the acrylamide and acrylates. All right, and these are a very different family of grouts, different applications. All right, so your acrylamide and acrylates are always a two-component system. We call it a solution grout. Always 1-to-1 ratio, so it's pretty easy to measure out. But the viscosity is one of the biggest advantages of the acrylate grouts. With acrylamide and acrylics, you're talking about a viscosity that is the same as water, which is 1 to 2 centipoise. That's extremely useful in some projects and some conditions. Then your acrylates are usually between 3 and 12 centipoise. They can permeate because they have the same viscosity as water. They can go anywhere water can go and permeate any defect that water can permeate or penetrate. Just like our hydrophobic urethanes, your acrylics and acrylates have controllable set times. You can set them to react anywhere from 10 seconds all the way up to 10 hours, depending on the application. If you had a high water flow situation, you might want something that's like 10 to 15 second reaction time or gel time. Whereas, Chris mentioned earlier, CH2 mentioned that one of our target applications is earthen dams. If you're injecting an acrylic into an earthen dam, you might want to kind of extend that gel time out to maybe 3 minutes, 5 minutes, 20 minutes. So that way it has more time to permeate and fan out, if you will, into the soil. So you can do that with acrylates. So some more specific information about acrylamide. It's an organic-based product. In other words, it's a byproduct of organic solids. It's been used for water control and soil stabilization for well over 50 years. So it's got a good history that's given us a lot of good data over the decades. I mentioned the viscosity being the same as water. Extremely long design life, long set times if you need them. A manageable toxic component. And after curing is completely inert, non-toxic, and irreversible. Acrylates are a little different. They're still a byproduct of organic solids, but they're still used for water control and soil solidification. A little bit higher viscosity, but not much. Instead of 1 to 2 centipoise, you're looking at around 3 to 4 centipoise. Still have controllable set times. And for instance, with our AV160, it's completely a non-toxic product. So getting into what does it look like, again, I mentioned earlier, it's a solution grout. So it's a 1-to-1 solution grout. So what you're seeing left and right are your A side and your B side. We've just put dyes, blue dye on the left, yellow dye on the right. Those are mixed together. And as they come together, you'll see no expansion and basically a cured flexible gel. Okay. So then we get into our third family, which is epoxies. Truly, between urethanes, acrylates, and epoxies, epoxy is kind of the, I guess you would call it the outlier in some ways, because epoxies are used for very specific structural applications. So for instance, they're used on static cracks. Epoxies may have a slight modulus of elasticity or elongation, but for the most part, they're completely rigid. Therefore, you would not use an epoxy on a dynamic crack or defect, only on static cracks or defects. They're not for water control. Epoxies do not play well in wet environments, and that's always been true. They might have some moisture tolerance, but best case scenario, best practices is that epoxies are injected into dry environments. All right. There's a wide range of viscosities, obviously low viscosity up to high viscosity, depending on your application. But the one thing about epoxies, and one of the reasons we refer to those as a structural product, is because they have an extremely high tensile and compressive strength, usually far more than the actual concrete itself. And epoxies come in 1-to-1, 2-to-1, even 3-to-1 mix ratios. So with that, I will hand it back to Mr. Britt for our third poll question.
All right. Thank you, Chris, Mr. OC. Our third poll question to our audience now is, what sector of the construction rehabilitation industry is most predominant for your company? So we have 4 different options there: residential, government utilities, private and commercial, or other. Great question for our audience. What sector of the construction rehabilitation industry is most predominant for your company? Take a few seconds here to let everybody respond. Chris, that was great information. Appreciate everything you guys are presenting.
Thank you, sir.
A few more moments here, let everybody respond, and we'll take a look at the results. All right, even spread, or closely, we're in the center part of our curve there, if you will, right in the middle. Even split almost there, government, utilities, and private commercial. A little bit of residential, a little bit of other. So interesting. It's always fascinating. So I know everybody's enjoying the material being presented, and we've still got more to come. Next up now is CH2, Christopher Hamilton from the Northeast Regional Manager. Chris, take it away.
Hello, everybody, once again. I know it's getting a little confusing going back and forth between the Chris's, but like I said, again, I cover the Northeast, so I'm going to kind of walk you through the basics of crack injection, kind of where what forms cracks, kind of walk you through types of materials you'll be looking at. So what causes cracks? As you can see there on the screen, there's many different things that can cause a crack in a structure. Whether it be a thermal or shrinkage cracking, which typically occurs because of evaporation of water, which causes uneven curing, and it allows the concrete to shrink a little bit. Whether it be movement, which is could be caused by settlement, expansive soils, poor pressure, point loading, or any other type of movement, which could lead to insufficient support of or uneven support of the structure, resulting in cracks. Could be from corrosion, which typically I came from the coatings industry. NACE actually defines corrosion as the natural deterioration that results when the surface reacts with the environment. So in that case, typically it's water. With steel, when steel starts to corrode, it'll actually expand up to 7 times its own volume, which causes a lot of spalling. Can also cause cracks. There could be external forces, whether it be could be pick holes in a manhole structure, could be somebody banging into a structure, could cause cracks in the structure. So as far as getting in the crack injection, the first step is assessing the crack. So the first thing you need to think about is whether or not the crack is going to be a static or a dynamic crack. Is it going to move? That's going to basically eliminate an epoxy situation if it's going to be a moving crack. You're going to kind of look at the type of or amount of water ingress, how much water is coming into the structure. That'll help you determine whether or not you need more accelerator or less accelerator, whether you need to heat your material to warm it up a little bit to help it react a little faster. And then you're going to look at the aperture width. So typically when the crack is very, very tight, less than 30 mils, you're going to have to go with a material that's almost the same viscosity as water, something that's very thin that can go in through those cracks. So we see a lot of this, especially in a lot in mines and tunnels and stuff like that where they have really, really tight cracks. That's where a high solids acrylate would come in handy. Something that's going to be able to flow through those cracks and then set up as a more rubbery type product. If it's over 30 mils, that's where you're going to hop between the different polyurethanes, which Chris addressed. And we have products that have viscosities ranging from 50 centipoise, which is about like an SAE 30 motor oil, up to 3,000 centipoise, which is like basically like honey. So as far as the different steps for crack injection, we do have a guide. If anybody does need that after the presentation, feel free to reach out to me or Chris. We can send it to you. But I'm going to kind of walk through the successful steps that illustrate the crack injection. So step one is drilling your holes. So your spacing typically is anywhere from about 10 inches up to, it could be up to a foot or two, depending on the application, the dynamics of the crack. When you're drilling the holes, you're going to want to come off about half the width of the structure. So if the wall is 8 inches thick, you're going to come off 4 inches, you're going to drill into 45. Reason being, you want to try to intersect the crack halfway in between. The reason you want to intersect the crack halfway in between is so when you pump the material, when it expands, it's going to fill the whole entire crack. After you drill your holes, you're going to flush them. You're going to flush the holes. The reason you do that is there's going to be residual dust that's going to come from drilling through that concrete. You don't want that in there because it'll mix with the grout and it'll prevent your travel. So you're going to have to tighten up your spacing. Your material won't travel very well. After you flush the holes, you're going to install your packers. Most of our packers, there's either a bolt or you turn the top of them and they expand at the bottom, which locks the packers in place so they can hold the pressure. The material is actually injected through a Zerk fitting, which is on the end of the packer. So after the packer is installed, most applicators will have a secondary water pump. They're going to actually hook onto that Zerk fitting and pump water through. What that does is it confirms that you drilled the holes that intersect the crack, flushes any dirt or debris that's inside of the crack that might hinder the material from flowing. It also helps determine whether or not you actually intersected the crack. You can actually feel the back pressure. If you don't, you'll actually be able to see the water flow through the crack. And it also provides the essential water. And if you're in an area where maybe it's not actively leaking at that time, that water you're injecting will actually help the resin that you're injecting react. So step 5 is injecting the material. Always start at the lowest possible point and work your way up. And basically, you're gonna inject the material until basically you feel back pressure, or until you pass the next hole, then work your way up. The rule of thumb, I always tell people to start on the lowest pressure possible, then work your way up as needed. You do not want to exceed 2.5 times the tensile strength of concrete. I actually did a demonstration with a contractor not too long ago, and his guy wanted to kind of see what would happen, and we blew the face of the concrete off and actually had material fly up in the air. So you want to make sure that anybody who's doing that actually kind of adheres to those rules. They don't want to blow up the face of the concrete. After you inject the material, you want to inject water. The reason you want to inject water is there's going to be some of that grout that maybe didn't hit the water that's on the backside, either inside the ports or on the backside of where the material's been injected. That'll actually react that material, so when you pull the ports, you don't have raw material that's going to spill out. After that, you're going to do the same thing on all the other drill holes, working your way up the structure. And then you're going to flush your pump extremely well. Typically, technical grade acetone is used. We do also have a pump wash you could use as a post flush. You don't want to leave the acetone in the pump for too long. It could actually eat away at some of the packings, which are plastic. As far as injection with epoxies, it's a slightly different technique. Instead of drilling in at an angle, epoxies are injected through gravity feed, and actually the ports are surface mounted over the crack. So basically, you would actually use the epoxy paste to cover the crack, surface mount your ports, and inject on low pressure and allow the material to flow through that crack and react and seal it, getting your structural strength there. With that, I'll pass it back to Britt for poll question number 4.
Thank you, Chris. Thank you. Next step in educating us on injection grouting. Appreciate everything you guys are talking about. It's fantastic. All right, next poll question for our audience. Is curtain grouting a good solution where high water flows or extensive networking of cracks are present? Yes or no? A simple two choice option there for your answer for our audience and attendees. Is curtain grouting a good solution where high water flows or extensive networking of cracks are present? Give it a few moments here, let everybody respond. Just a few more seconds here. Is curtain grouting a good solution? And our results are yes, 78%, and no's are 22%. So very, very, very interesting. I think I would have to say I think the yays have it on that one, but I'll let Mr. OC, original Chris, inform us all about curtain grouting. And Chris, I'll let you take it away.
All right. Thank you, Britt. So CH2 just talked to you about crack injection using either polyurethane and or epoxy resins. So what I'm going to talk to you about is curtain grouting and just kind of getting into the specifics of curtain grouting and what kind of guides us down that path. So what is curtain grouting? Well, basically, curtain grouting is creating an impermeable barrier on the back side or on the positive side of hydraulic flow of any structure. And when we talk about curtain grouting, you may have heard it called encapsulation grouting. That's not uncommon. But we could be talking about any structure. We could be talking about a wall below grade of a parking structure or a manhole, a sanitary sewer manhole. Could be any number of things. So what is curtain grouting? Well, like I said, it's basically an impermeable barrier, but it's using grouts, either expanding or non-expanding, to prevent water from contacting or passing by a structure. So essentially, it goes back to what we just said a moment ago. We're creating a barrier on the positive side of hydraulic flow. That's kind of the basic definition. What guides us down the path of curtain grouting, though? Well, when we look at a project, what says to us, okay, I'm going to have to curtain grout this wall instead of crack injection or point repair? Well, the first thing is we look at cost, like all of us do, and that's usually our first consideration. So crack injection itself would be cost prohibitive. That's usually a place where we would drop back to curtain grouting. Why would crack injection be cost prohibitive? Well, maybe there's an access issue. Maybe it's you would have to demolish part of the structure to get to, to have access to do crack injection. That's one thing. Brick and block structures. Typically with CMU walls, which I'm sure we all see very commonly underground, you don't want to really try to point repair that because you're essentially drilling into hollow core block. One thing we see very commonly in the sanitary sewer system is brick manholes, and believe it or not, probably 40% of our sanitary sewer system is still brick manholes and not precast. Well, you go into a brick manhole, let's say it's 8 feet deep, you might have 300 to 400 linear feet of motor joints that are leaking. In that setting, you could be there for 3 or 4 days trying to crack inject or point repair all of the motor joints. So in cases like that, it's just faster, it's more cost effective, and time efficient to go ahead and curtain grout it. Concrete with extensive cracking. I know we've all seen at some point in time where you approach a concrete wall, maybe it's a tank wall, and you've got an extensive network or what we call spider webbing of cracks, and you know that you're going to have to put 1,000 ports in a 5 square foot place to try to crack inject. So in some of those cases, you're better off looking at curtain grouting as an option. Unconsolidated honeycomb concrete or mal consolidation. Typically, you want to go ahead and pump behind the wall instead of trying to pump into a honeycomb because drilling into that's going to be problematic anyway. Belt and suspenders approach. What we mean by that is, as a contractor, as an applicator, you may go ahead and inject the cracks. Maybe they're accessible and it makes sense. They're very defined. But in order to kind of offer your client or your customer a second layer of protection, you give them the belt and suspenders approach of injecting the cracks and putting a barrier on the back side of the wall. That's usually a very good approach. if you have a very high rate of infiltration. Sometimes I was on a dam not too long ago, and we were injecting a very specific crack in concrete, but the lake water was just coming in so fast, it was very hard for the grout to catch up. We had to drill further back and essentially pump somewhat of a grout curtain on the backside of the crack. So that's one case you might run into. And the last thing is cracks or defects are too tight to be injected. This is not uncommon either. A lot of times when you see those networks of cracks in a slab or a tank wall, or a manhole, whatever it may be, or even a vault, what you find is if it's a spiderweb crack, a lot of times those cracks are so tight you can't really inject those. So your only choice is to pump behind the wall and create that barrier or that mat, if you will, behind the wall. So talking about the process, Chris went through again the process on crack injection specifically. So I'm going to talk to you loosely about the process of curtain grouting. And really, again, I have to say it's very different from crack injection. So the first thing to tell you is that, and as I'm sure you can imagine, the holes are drilled for the injection of grout and extend to the entirety of the structure. It's a really fancy way of just telling you we're punching all the way through the wall, okay? We're going to drill all the way through the wall until our bit arrives into the soil behind the wall. Things you need to know before you do this, though, and obviously, the more you know, the better you are, right? But the first thing is we need to know what type of soil is on the backside of this wall. Are we dealing with clays? Are we dealing with sandy soils? Because the way your grout reacts behind the wall is going to be very different. Not really how it reacts, but how it moves specifically. It's going to be very different based on what type of soil you have outside. Is it 89 stone? Is it sand? Is it clay? The next thing is potential contaminants within the soil outside of the structure. So not too terribly long ago, we did a project in Savannah, Georgia. It was a storm trench that was essentially concrete storm trench or spillway, but it was near some railroad yards, right? And so we knew that there was a high level of creosote and crude oil outside of this storm spillway. And so when we punched through that, we got creosote coming back at us. And those are things you need to know, especially if you're the one that's down there doing the drilling and pumping. Pilot test using dyes. What that means is a lot of times when you start to drill your holes, you can find out how your grout is going to travel by pre-pumping water, dyed water specifically. And that's going to tell you a lot about how your grout's going to travel when you start pumping grout. Core samples, truth be told, they're great to have. Any type of soil reports or information like that's great to have, but the truth is you rarely get that. And that's the reality of construction. And then the last thing is we want to ask the question, especially if you're the contractor, especially if you're the applicator, what is outside of this wall? Is there a roll applied coating outside of the wall for waterproofing? Is there sheet applied waterproofing of some sort, drainage board, tile, etc.? We need to know what's outside of the wall. Again, the more you know, I just can't say it enough, the more you know, the better off you are. So talking about the grid pattern, this is a very generic grid pattern that we're looking at, but it kind of gives you an idea of what curtain grouting is and how it's applied. So if you look at this grid pattern that we've got on the screen right now, you've got 10 feet spacing laterally and you've got 5 feet spacing vertically, okay? Do notice, though, a couple things to note. Number one, they're staggered, right? What we're trying to do is we're trying to create as consistent a mat as possible on the backside of the wall. And the best way to do that is to stagger your holes, right? So that no area is left untreated. A few things to tell you about this. First of all, we're showing 10 lateral, 5 vertical spacing. But a lot of times you may find you need to bring those holes in. Sometimes it's a good idea to start at 2 to 3 feet spacing and then see how your grout travels. But one of the other most important facts to share with you about this is that we always start at the bottom and we work our way up. And if you're not very familiar with grouting, that's fine, but you may ask, why do you start at the bottom and work your way up as opposed to starting at the top and working your way down? Well, as we're pumping this first row at the bottom, okay, that grout's starting to expand all through here. Now, why is that important? Because what we're doing is we are pumping, injecting, and creating what becomes a shelf, so that everything we pump after the fact in our next holes moving up in procession, now they have a shelf to sit on. They won't continue to settle down via gravity. They'll actually work their way left, right, and up, which is what we want. Okay? So this is kind of a generic grid pattern. One thing that I like to do personally is, mentioned earlier, pumping water first. So I'll drill my first holes, and I'll get, maybe 10 or 15 holes in place, and I'll pump water. And what I'm looking for is I'm looking for water to move to my next hole in procession. So I'm pumping here in the first corner, and I'm looking for water to move over here. Now, if I pump 10, 15, 20 gallons of water, and I'm not seeing any communication, what we call communication between holes, what I may do is I may drop back and pump a hole right in between. So instead of having 10-foot spacing, I would have 5-foot spacing. Okay? Sometimes that's necessary, and sometimes that's how you are able to determine what your spacing should be. But as a good rule of thumb, 3 feet spacing on centers is kind of a good starting point. So the second step, go ahead and put in your first injection port. Okay? Put in your first injection port, not anymore. A lot of people say, well, should we just go ahead and drill it and set the ports and get everything ready to pump? And my answer to you would be no. The reason being is because if we go back to this grid pattern, all right, if I have a port in this hole and I have a port in every hole, guess what I've done? I have closed off my ability to verify communication between holes. Now, you and I, as good as we may be, we can't see what's happening outside the wall, right? So the only way that we can visually verify that we're creating good coverage on the back side is to leave these holes open and verify that we are getting material communication from hole to hole. That is the only way that we as applicators can tell for sure that we're creating that uniform mat on the back side of the wall. So my suggestion is, and I think our best practice really is to set the first injection port, begin pumping it, and as your grout moves to the next hole in procession, then set your injection port in the next hole. Okay? So now we've set our first port, we've drilled our pattern out, we've set our first port, now we're injecting grout. Again, I tell you, we start at the bottom, we work our way up, right? So we're going to start to the left. And as we pump, we've already built that shelf, which I referred to just a moment ago, and we're going to stagger our holes. We're going to continue building on that shelf, staggering the whole way until we reach the top. All right? And that is the kind of overlap, if you will, of a good curtain grout application. So the last thing I'm going to talk to you about, one of the questions we get all the time, as you can imagine, is how do we pump this? Where do we put it? What equipment do we use? What do we need? There's a huge misconception, whether you're a self-performing utility or whether you're a contractor that's maybe looking at getting into this type of work as a value-added service to your customers. The question is always, what equipment? The misconception is that pumping grout, no matter what type of grout you're pumping, is a huge production and it's highly costly and you got to have all this equipment and everything. And really, nothing could be further from the truth. When you're looking at the conveyance equipment, you have so many options at your disposal, and none of them are massive investments or huge productions. You can start with cartridges that go through a regular caulking gun, right? Caulking gun that you can get anywhere, right? We're talking about a $7 to $8 piece of equipment. There are dual cartridges, both in urethanes and epoxies, that go through a standard dual cartridge gun. But then let's say that maybe you want to increase your efficiency. You want to speed up your productivity. So then you would step up to a pump system. Well, when you look at the pumps that every contractor and every self-performing utility uses for efficiency and productivity, what we're typically talking about is nothing more than airless paint sprayer pumps. All right, here we've got a few in the picture, Graco 390 or 490, but these are electric powered, very portable, and very efficient. They work very well. And then when you get into the acrylics and acrylates, something where you've got plural component products, a 1-to-1 ratio product, then you've got the WEWA pump, which again is just a plural component 1-to-1 pump. That's a pneumatic pump, but the point that I want to make to you in this slide is that you have a lot of options and none are massive productions. So with that, I'm going to hand it back over. And if you would, Chris, take it away.
All right. So I'm going to walk through some projects that have been done in the Northeast within the past few years. Just walking through some of the different techniques that me and Chris have gone over through this presentation, as well as some of the products, just so you guys can see some applications. There may be some ideas generated, or might be some questions that might come up about some of these projects as I'm going through. So the first one I'm going to do is actually, we set a world record with PSE&G. It was a CIPL natural gas main that went underneath the New Jersey Turnpike. They actually had infiltration coming in. The pipe went out and then down at a 45, out and then down at a 60. The customer had to build his own custom pulley system to get his guys down there. They actually drilled through the steel pipe, tapped in the zerks, patched and repaired the pipe where the corrosion had occurred with an epoxy, basically to patch and repair to prevent some of the heavy infiltration so they could kind of fill the voids. And then they tapped the zerks in and injected our AV275 to the outside. Basically, they hit all the joints where the infiltration was occurring most heavily. The material locked the soils together on the outside, formed a barrier around the structure, and prevented the water from coming in so that they could actually put the liner inside that structure. This project was actually done. It used to be at one point it was a hotel that had a parking garage underneath it. At one point the hotel had changed hands. They changed it into a multifamily housing type facility. When they changed hands, there used to be a drive-in parking garage that was underneath the structure, so you had to go down and then back down underneath. They actually blocked off that wall so they could use the basement as storage. And what happened is, next to this structure, they were going to build another structure. They actually dug the foundation for it, and the contractor who dug the foundation didn't have a permit and actually ended up getting pushed off the site. So the whole pit next to this project actually filled with water. So they had heavy infiltration coming in through the block throughout the whole building. There was actually a contractor at one point who was trying to inject into the blocks. And as Chris said earlier, when you're doing any type of CMU type block, the best idea is actually drill and pump the material to the outside. So we helped the contractor basically with a game plan for drilling into the joints in between the block and pumping our material on the outside. And basically they filled the whole outside, stabilized the soils. You can see the result there where it stopped all the water from coming through the structure. After that, they actually coated the walls in there, and actually looks pretty nice to this day. This one is an example of a double barrel sewer project. So this sewer was big enough you could actually drive a car through it. They had about 2 million gallons of water coming up through the bottom of this sewer. We helped them stop that water, but we told them when that happened that what was going to happen was they were going to have water that was going to come out through cracks, because basically that water's got to go somewhere. It's going to build up. It could come out in other areas. So they sealed the bottom of the floor, stopping all that infiltration. And as the water built up, it started to come out through cracks all through the wall. So the contractor did a crack injection. You can see there on the right, he's coming in at an angle and injecting the material. They actually walked down the sewer, injecting all the cracks in this double barrel sewer the whole length. That was actually our AB248. Here's a picture of an elevator pit that was done in Manhattan. They had heavy inflow, and you can actually still see where it's a little bit dark there. It was at the floor wall joint. A lot of times what happens is you have a poured floor. They put precast sections down on top, and then it leaks at that floor wall joint when maybe maybe a water stop or something will fail over time. The applicator drilled down at an angle and pumped our AV275 to the backside of the structure. AV275 worked very well because it's low in viscosity, high expansion, so it mixed in with the soils, expanded, locked it all together, and built a barrier around the outside, preventing that infiltration. After they prevented the infiltration, they dried out the pit, and then they put a coating on the inside, an acrylic coating. This project was probably one of the coolest ones I've been on in my time. That ladder right there was about 40 feet to crawl down. I always tell everybody I'm afraid of heights, so that was it was interesting. We actually had to build scaffolding inside of the tank, and on the ceiling, all the joints were leaking, and they had groundwater that was leaking through those joints down into the clean water inside the tank. A tank held 17.5 million gallons of water. So we actually we walked through the training procedures with the contractor, crack injection, and ended up injecting all the cracks and joints throughout that structure. That I'll pass it back to Britt for the question and answers.
All right, fantastic. Thank you, Chris. And Chris. Thank you, Chris and Chris. The Chris's. OC, original Chris, and CH2, Chris Hamilton, Christopher M. Hamilton. Great information, guys. Great information. All right, we're into our Q&A session, and I'm going to open up some of the questions that we've gotten. We've got several here, more than what we're going to be able to get to. One of the first questions is, which type of grout, again, would I use for curtain grouting in a urethane situation? Let's say I'm going to do curtain grouting around a manhole. Which is a thicker or a thinner product better? OC, would you take that question?
Yep, sure will. So especially if you're curtain grouting around manholes, you're probably going to be doing that because it's a brick manhole and point repair, crack injection is just not feasible. So in that setting, my go-to, I mean, there's obviously a lot of things that drive it, but my go-to is AV275 soil grout because very low viscosity, hydrophobic, cures rigid to semi-rigid, so it's got some strength to it. It uses a catalyst, so if I want to slow down the reaction and allow it to kind of permeate around the manhole, especially a manhole, I'm able to do that with the catalyst. So low viscosity, high expansion, hydrophobic is kind of would be my fallback in that 275 soil grout.
All right, thank you, Chris. One of the things that often gets wrapped around that question too is I've gotten a bolt-on to that question is the use of acrylics for curtain grouting around manholes. Does that happen? Do people sometimes use acrylics as well versus urethanes?
You know, I think I see probably 80% urethanes and 20% acrylics in that setting.
Yeah, that's I know we do see that from time to time, so that's why I asked that question. All right, one of the other questions here. Talk about pump preparation. How do they avoid contaminating the pump? OC, will you take that one again, if you don't mind? CH2, I've got a few lined up for you as well, but how do you ensure that you don't seize up, contaminate your pump? What's the best way to prep your pump in that situation?
All right, so one thing, the first rule of thumb is no matter what structure you're working on, whether you're doing curtain grouting, whether you're doing crack injection, the one common denominator that's really important is do not try to use the same pump for pumping water. We talked about pre-pumping water both in crack injection and curtain grouting. Always use a separate pump. Remember that no matter whether you're using a hydrophilic or hydrophilic polyurethane, they're all moisture or water activated, right? And so you always want to use a separate pump. The good news is that your water pump can be a real cheap pump, because you're pumping something with hardly no viscosity, being water, 1 to 2 centipoise. And so you don't need a big industrial sized pump for that. The other thing, as far as good best practices for your grout pump, is when you get done, we recommend, like CH2 said earlier, technical grade acetone. And we recommend that not because acetone's a great solvent, okay? We recommend acetone because it has no water in it. And remember, again, we're dealing with moisture or water activated resins. I personally flush my pump out until I have a clean stream of acetone, and then I recirculate that clean acetone for a few minutes just to make sure. And then, I'll run pump wash or even vegetable oil through my pump to kind of recondition the seal. So flush, and don't use the same pump for water and grout. Thanks, Britt.
All right. Thank you, Chris. All right. CH2, question for you. This question is around volume usage, and it's how do we estimate how much grout that we're going to use when crack injected? And what does it depend on? Is it crack width, crack depth, or both?
Well, it's actually going to be off of both. You're going to be able to you can get pretty close estimate by calculating the cubic feet of volume of the crack by knowing the width, depth, and depth of the crack, and you can calculate the cubic feet yield of the material. Gets you a pretty good ballpark. It's all going to depend on the width and the depth of the crack and depth of the wall.
One of the questions that I've had, piggyback onto that if I could, how does expansion play into that calculation when you're injecting into a crack, or does it play into the calculation?
Well, it does when you're calculating. How I do it is I usually calculate the cubic foot yield of the material that we're using. So that the expansion of the material is going to factor into that calculation. So if you're trying to figure out how much material you're going to need, you'll be able to calculate your whole yield of the actual crack, and then how much material you're going to need based off of that, and with the expansion included.
Yeah, great answer. Great answer. Thank you, CH2. All right, we're coming up on our end time here. We're going to stop with our Q&A now, and many more questions there. I appreciate everybody's insightful questions, and I'm sorry we weren't able to get to all of them. One of the things that we at Avanti, we're always leading with education, trying to raise the tide and share what we know. We enjoy learning just as much from you as we do sharing what we know with you. And so as part of our sharing with you, these are 3 promise documents that you're going to receive in email from Avanti. First is going to be our variable pressure application technical manual, or more affectionately called our VPAT technical manual. You'll also receive our curtain grouting brochure manual. It goes in and talks about manholes, vaults, and underground structures. And then our how-to guide on epoxy crack sealing for paste and crack injection. So look for that in your emails. I appreciate everybody's time, but before we close out, Chris, would you like to OC any closing statements?
Absolutely. Listen, thank you all for attending, for the questions, and taking the time to do this and move the needle forward in education. I can't encourage you enough to give us a call and let us be of assistance to you. That's what we're here for. You're not out there on your own. You don't have to take these projects on your own. You've got help. And thanks again.
All right. Thank you, OC. Mr. CH2, closing comment from you.
I second what Chris said there. If you guys need assistance, feel free to reach out. We're all of our RMs are more than willing to come out and get our hands dirty and help you guys out. Or if you need help with specifications or even product selection, feel free to reach out. We're here to help.
All right. Thank you. Before we close out, I would like to give credit to Miss Jessica Williams. I don't know if very many people on this call know who she is. Maybe you do. Hopefully you do. And if you don't, you should. She is our marketing manager, and she has been the backbone and the quarterback in pulling together this webinar series. And I want to give a gratitude of thanks to her all her efforts, time, effort, energy in pulling this together. So thank you, Jessica. Again, I'm Britt Babcock, president for Avanti. Grateful for everybody's attendance on this webinar. Look for a next webinar from us in our geotechnical series, or in our webinar series will be on geotechnical grouting. Thank you so much, and everybody be safe, both you and your families, and look forward and pray for an expedient closure to this pandemic. Thank you.